In this video, in our linear equations chapter, we're finally going to look at all the steps for solving a linear equation, including this first one of getting rid of fractions. So when you look at example 1, the first thing you should notice is that you have fractions, you have denominators, where you did not have denominators up to now when we stopped with this step, when distribute was our first step. So the first thing that we want to do whenever you see a denominator is you want to look at those denominators, 2 and 3. Remember, these are not denominators. These whole numbers are over 1. So those are not denominators. 2 and 3 are the denominator. And I want to know, what is the LCD for 2 and 3? It's 6. So I'm going to rewrite my equation so I have a little bit more space. And what you want to do is you want to put each term in parentheses. Now remember, terms are separated by pluses, minuses, and equal signs. So here I have a term, separator, term, separator, term. This is all one term, separator, term. You want each one of them in parentheses. And it probably would be a good idea to go ahead and put your whole numbers over 1. Now what we do is we take this LCD and we write it beside each term, and you got to kind of squeeze it in. And I realize that makes things look very messy momentarily. The reason you do that is because it will now cause all of our original denominators to cross cancel. So by putting the parentheses, we're setting up multiplication. By writing the LCD beside it, we're going to cross cancel that denominator, and we have 3x on our first term. Here there's nothing to cross cancel, but I still have to multiply the 1 times the 6. Here 3 goes into 6 2 times. And what's left is 2 times 2 times x, or 4x. Here there's nothing to cross cancel, but I still have to multiply 3 times 6. So big note to self. You put the LCD beside every term, not just the terms that have fractions, but every term. And now we go ahead, we have gotten rid of the fractions. We're going to distribute, combine like terms, get variables equal to numbers, and divide, just like we've done up to now. So next, distribute. I don't have one, so I don't have to do it. Combine like terms. There's no like terms on the left or the right. Don't need to do it. Next, get my variables together. I'm going to do that by subtracting a 3x. Yes, I could have subtracted a 4x. I chose not to. I hope by now you figured out why. Negative 6 equals 4x minus 3x is 1x minus 18. So the variables are now here on the right, so the numbers have to go to the left. So I'm going to add an 18. X equals 12. And there's nothing to divide because it's a 1. So I don't need to do that. And I have my solution. And we did that by getting rid of the fractions. You're just going to have to get used to it because that's the way that you solve if there's a fraction. So looking here, I have a denominator of 3, 2, and 6. So the LCD for those 3 numbers just happens to also be 6. So again, let's write our equation so that we have a little bit more space. And now we're going to, let's put that over 1. We're going to put every term, so term, separator in parentheses, term, separator, term, separator, term. Every term is in parentheses. We write the LCD over 1. And again, you just have to squeeze it in, except for the ones on the end have plenty of space. And now all denominators will cross cancel. 3 goes into 3 once. It goes into 6 twice. 2 times 2 times x, 4x. 2 goes into 6 3 times. 3 times 1x, 3x. 6 goes into 6, and notice there's still a negative there, so be careful. Minus 1x on that side, or just minus x. And then here there's nothing to cross cancel, so it's just 2 times 6 is 12. So we got rid of fractions. Do you see a distributive property? No, so we don't need to do that. Are there like terms to combine? Yes, there are on this side. 4x minus 3x is 1x equals negative 1x plus 12. Those are not like, so I can't combine those. Are my variables together? No, they're not, but my numbers are. My numbers are over here on the right are all together. So my number terms are together. I have to move my variable terms to the other side by adding a 1x. So 2x equals 12, and that step is complete. And now the last step is to divide by the coefficient of x, and I get x equals 6. And we solved it by doing all of the steps. Let's try two more that look a little bit different, but they work the same way. You're going to be more likely to make a mistake here. I'm going to go ahead and put my whole number terms over 1 immediately so I can see my denominators. And all I really have are 3 and 1, 1. So my LCD here is just 3. So let's write our equation again. Put each term in parentheses. That's what you do first. You do not distribute first. So I already have parentheses, so I'm going to use brackets there. And then parentheses and parentheses. There are 3 terms there. My LCD is 3, so I'm going to write 3 over 1, 3 over 1, 3 over 1. These 3's cross cancel, and what is left is a 2 times an a plus 3. Notice I didn't distribute. I didn't do 2 steps in one. All I'm doing is getting rid of fractions. Here, nothing to cross cancel. 3 times 6a is 18a. 2 times 3 is 6. Now we're ready to distribute, and I do have something to distribute, a 2. So 2a, don't forget this one, plus 6 equals 18a plus 6. Combine like terms on each side. Well, they're not alike, so I can't combine them. Are the variables together? No, but I'm going to get them together by subtracting a 2a. I get 6 equals 16a plus 6. So now my variables are on the left. Let's get the numbers together by moving this to the right. That gives me 0 equals 16a. 0 is a number, so don't think it's not. Last step, we divide by the coefficient of a. So I divide by 16, and I get a equals 0, a legitimate answer, by following every step. Let's do another one that's like that, starting with get rid of fractions. So again, I'm going to rewrite just to give us more space. I'm going to go ahead and put this in brackets because I know that's one whole term, equals negative 2m over 1. That's a term. Minus 6 over 1. That's a term. I have 3 terms. My denominator is just 4. So my LCD is 4. I'm going to multiply each term by 4 over 1. 4 over 1, like that. The ones that have denominators will cross cancel. I didn't mean to cross out that negative. Be careful of that. It's easy to do that. So what's left here is negative 3 times m minus 2 equals nothing cross cancel. So I have 4 times negative 2m, negative 8m, minus 24. 6 times 4. Done. Now we distribute. Negative 3 times m is negative 3m. Negative 3 times negative 2 is positive 6. Nothing to distribute here. We combine like terms. Those aren't alike, those aren't alike, so don't do it. Get your variables together. I'm going to get them on the left by adding an 8m. See if you can figure out why I added the 8m instead of adding the 3m. This gives me a 5m plus 6 equals negative 24. Now the variables are on the left, so we have to get the numbers on the right by doing the opposite. So 5m equals negative 30, and that step is done. The only thing left to do is divide by that coefficient, and I get m equals -6. So getting rid of the fractions first. Let's look at two final ones that are rather odd in what happens, but we're still going to follow our same steps: fractions, distribute, combine, variables equal numbers, and divide on both of them. So here I don't have any fractions. Don't need to do it. So we're going to distribute -2 times x, -2 times -5, +10, neighborhood kid. Here I have another number to distribute, a -3. So -3x minus 6, -3 times +2, and then a neighborhood kid. Done. Combine like terms on each side. Here I have -2x plus 20. Here I have a -3x, and a positive x is a -2x minus 6. So I combined. Now I want to get my variables together. So I'm going to add a 2x, and here is where it gets interesting. That makes a 0, but it also makes a 0 here. And what we have left is 20 equals -6. So let me ask you, is that ever true? That's what you want to ask yourself. When is that true? That is never true. Now that's not the answer, but that's what helps you get to the answer. If it's never true, then what that is saying to you is that there is no solution. There is never an answer that's going to work. There is no solution. Now let me show you something. You can write that like this. That does not mean 0. What that means is the empty set or no solution. So by the way, don't make your zeros with a line through it, because it means something different in math than it does in computer programming. So that's a case where we got something ridiculous. 20 never equals -6. Let me pull that back down. So we know there's no solution. Now let's look at this one again, following those same steps. There's no fractions. Let's distribute. 3x minus 12 equals 3x minus 12. You might feel suspicious already because it's kind of weird. There's no like terms to combine. Let's get our variables together by subtracting a 3x, and I get -12 equals -12. Well, when is that true? That is always true. And because it's always true, then there are all answers or infinite solutions, meaning anything that I put in for x is going to work. So this one came up with something that's always true, infinite solutions. This one came up with something that's never true, it's ridiculous, so there's no solution. And as always, there are some on your own problems that you need to work on, and then we will answer questions about those in class.